at the SEV, and I am a rising junior at Grinnell College in Grinnell, Iowa. My research this summer was on the natural and artificial springs in ecosystems and their influence on the macro invertebrate communities within them. So, the effects of the Anthropocene. How many people have heard of the Anthropocene before? So a lot of REU students, we had a seminar on it. It was really interesting. But for those of you who don't know what the Anthropocene is, I can give you a definition. This term refers to the current geological age of our time. So what we're going through right now. It's viewed as the period in which human activity has been the dominant influence on both the climate and the environment around us. So that essentially is arguing that humans are a keystone species. We are having a disproportionate effect on the environment to our population size. So what does this mean? Do we see the effects of this in the Southwest? And yes, we do. We especially see the effects of the Anthropocene when we talk about issues of water. So, New Mexico is a little dry. We have some patterns. In June of 2010, we had a normal drought condition in New Mexico. We had a little bit of water, still a little dry. In 2013, 45% of the state was in exceptional drought, which is the highest designation of drought by the U.S. Drought Monitor. This year, even though it was our El Nino year, in June, we still had 1% of the state in exceptional drought, but 85% in extreme drought, which is the bright orange. So the way to look at this map, the lighter colors means there's water. The darker, increasing shades of red means it's really, really, really dry. And just for a point of reference, the Sevilleta is located in Socorro County, which is this nice little shape here. You might be wondering why I'm using June 2010, June 2013, and June 2014, and the lag in the years. That's because I have data on the macroinvertebrate communities on the set from June 2010, from last year, and I did the research this year, so there's data. So, this is why artificial springs are important. The rivers are under high stress, and they're becoming increasingly fragmented with the rising temperatures and rising aridity. These natural and artificial springs are oftentimes the only source of water for the biota to utilize. They're reliable and they're stable. Sorry. Yes. So that's why they are really important. They're awesome. Not only are they creating this ecosystem for this foundation for a large ecosystem, they are also creating an internal ecosystem filled with these little critters. These little critters are really important for lots of things. They are not only maintaining the health of the aquatic ecosystem by being a food source for other invertebrates in there, they're also decomposing organic material that falls in there and cleaning the water. They also provide a food source for larger animals outside of the water. So the bats sweep in and eat these, which help pollinate all the flowers. They're really important for that. They're also creating a healthy water system for the other animals who are using this and the vegetation that's growing around it. They're really cool. So knowing all this, it led me to a few research questions. I wanted to know if diversity and abundance of these macroinvertebrate communities had any relationship with natural versus artificial ecosystems. I also wanted to know how these critters were surviving increasing aridity. Are they coming back year after year, or are we seeing a decrease in their abundance and in the diversity? So, this is why I'm at the Sevilleta. The Sevilleta is the perfect place to study this because there are over 40 springs throughout the refuge. The refuge is 230,000 acres. It's really big. And there are both natural springs, which are occurring naturally, and artificial springs that have been put in by humans. Effects of the Anthropocene. So, my study sites. I studied 13 different springs on the Sevilleta, and I had 5 natural springs. San Lorenzo, Canyon del Ojito, Four Springs, the Rio Salado Spring, and Sevilleta Spring. As you can see, these are in very different habitats. Some are pressed against rocks, these little box canyons. Some are just shooting from the ground with lots of vegetation. They're very different compared to my 8 artificial springs. Goat Draw, it's that little box right there. West Mesa, Gibbs, 222, West Mesa Tire, Esquivel, Mackenzie, and Nunn. As you can see, these ones are all very similar. They have been installed here prior to the refuge designation. When this used to be a cattle ranch, these artificial wells were cattle drinkers because there's not that much water on the Sev. So the cattle needed places to use. When the refuge was designated and took over this area, they maintained these. And these are being utilized by both pronghorns and large mammals as well as the macroinvertebrate communities. So how did I study this? I went around to all my 13 sites, which are both on the east side of the refuge and the west side, and I collected water samples. I also collected soil samples and did a quick vegetation and habitat appraisal, meaning I went there, looked around from 1 meter to 10 meters out surrounding each spring, and took note of what was growing. And I have results. I'm quite excited. So in this graph, this shows the total abundance of the macroinvertebrates in natural and artificial. The blue are the natural springs, and the orange shows the artificial springs, those drinkers that I was showing you in the ground. This definitely indicates a trend. There is a trend that the natural springs they have the perfect environment for lots of macroinvertebrates to utilize. But this is just a trend. When we break it down and look at it individually from each one, we see that the data might be a little skewed because San Lorenzo Canyon had 512 animals, or organisms. There were a lot of chironomids, which are these little worms. I counted 394 of them under the microscope. It's fascinating. And as you can see, this shows that it might not be as simple as just natural and artificial. Some of it tends to be a little random. But when I looked at diversity, there was a statistically significant trend, which was really exciting. So I did a two-way t-test on my data and found a p-value of 0.015. And what it means when something is statistically significant is that I am over 95% sure that this data is not just random. There is definitely a relationship between diversity, natural springs, and artificial springs. When you look at this, it's very apparent that natural springs have a lot more taxonomic richness, meaning you could just find really unique and interesting things here compared to when you just have artificial springs. When we break it down individually again, you can see that this trend is a lot more apparent than the last one. This is why it is statistically significant. Okay, well, what's really in the wells? No, I do. So, I found 20 different, I was IDing only down to families. I found 20 different families, meaning 20 different types of individuals in here. I did not go down to genus or species because that's really hard with macroinvertebrates. I'm not an expert yet, so there is also a bit of a time crunch. But this gives you a really cool idea of what's going on here. The colors are a little bad, but I can walk you through this. So there are 20 families. The ones in green, which are, colors are really bad, but the Chironomidae, the Stratiomidae, the Caryxidae, the Mesovilidae, and the Dytiscidae, and the Betae, those were found in both natural springs and artificial springs. These are very resilient macroinvertebrates, and it's awesome that they're doing so well. When we look at only the artificial springs, they had 4 that were unique to them and only found in artificial. That was the Tipulidae, Palidae, Hydrocinidae, and the Unidae. But what was really cool when you looked at what we were finding in the natural springs, there were 10 that were only found in natural springs. And that is really cool. It just shows that there is a lot of diversity happening in these naturally occurring environments that is not provided or sustained in the artificial realm. So you might remember my other question is, how are they faring? How are they faring with the increasing aridity and the increasing effects of us humans in the environment? Well, based on data, they're doing pretty well, which I was surprised but very pleased to find out. The blue bar graph, that represents data from 2010, and these are wells that were sampled each year. Continuation. I did more than what's shown here, but these are ones I have macro data for. The red is 2013. That was our huge drought. You might notice on the end at Sevilleta was completely dry. There was no water. And so there was no diversity. There was nothing living there at the moment. Compared to 2014, which is the bright green, kind of yellow looking, I'm seeing a very high increase in taxonomic richness, in the different amount of species that I'm finding in each of these wells. I did not have data on the abundance, I only did diversity. So what to take away? Does diversity and abundance of aquatic macroinvertebrates vary in natural versus artificial springs? Yes! Yes, it does! What does this mean, though? We saw that artificial wells, like the one on the left, they aquatic macroinvertebrates react to increasing aridity. Despite New Mexico being one of the driest of the dry, this is a headline from the Los Angeles Times from last summer when we had our incredible drought. They seem to be doing really well. They seem to be very resilient animals, which is good for both their communities, but also for the larger communities that they become the foundation of, like the foundational food support for bats and water health and larger mammals. Future directions? I believe that the springs should be continued to be monitored. This would be important to continue to have this baseline data so we can see what's happening. Macroinvertebrates, these insects and bugs, they have really short lifespans, so they turn over rather quickly. And it would be interesting to monitor them as they are very sensitive to habitat destruction, pollution, etc. I also think water quality should be assessed. I would have liked to have done this summer, but I did not get equipment until like 3/4 of the way in, and it was a little hard to backtrack to other springs and assess the water quality. But I think this would be important to complement the other research. I also think that the macroinvertebrates should be identified further to the species level if possible. A lot of these macroinvertebrates have different feeding patterns based on if they're larval or if they're pupa, and knowing their exact species will give us a better picture of the relationships within the well. If it's a very carnivorous well where everything's eating each other, or if it's more balanced, happy, ideal, utopia. I also think a spatial analysis would be really important. Is it really only a factor, a variable between natural and artificial? Is this really what's happening here? Or are stuff that are closer together fostering the same communities? Are they being carried over by birds, utilizing each spring? And so I think this would be really interesting. With that said, thank you to everyone who supported me this summer. Thanks to Asha Burdett, my mentor, who is unfortunately not here today. She is in Australia, on the other side of the world. Thanks to Amber Swan for being amazingly supportive. Thanks to Ben, also supported and helped me with some of my stuff, building the lay trap that I did not get to utilize fully. Thanks to Kathy Granillo and all the Fish and Wildlife staff for helping me with this project. Thanks to everyone else who was here which is pictured here, she was my very stable, dependent field partner. I named her Lois. We went on lots of adventures. I managed